Dear colleague, welcome. My name is Hande Mutlu Öztürk. I am a Turkish researcher and I work in the field of gastronomy, food system and sustainability with a particular focus on translating scientific and engineering concepts into practical food system solutions. Welcome to the courses. We start today with food recovery, redistribution and donation system, and I will not approach food waste from a purely ethical or emotional perspective, but rather from a technical, systemic and engineering-oriented standpoint. We are not gathered here today simply to express a romantic wish like, let's not throw food away. Today we will discuss the war we are waging against the laws of thermodynamics, especially how to integrate circular economy principle into the food system using the language of engineering. As you know, entropy in the universe tends to increase, and unfortunately, our food supply chain serves this cause perfectly. However, our job is to bring order to this cause through food recovery engineering. In this part, we will discuss the technical and operational framework required to recover surplus food within the supply chain before it turns into waste. It's explored the food recovery hierarchy, logistical optimization, digital integration, and legal frameworks like the Good Samaritan Laws. Our objective is to move from theory to practical engineering-based solutions for surplus food recovery. You will gain the ability to navigate regulatory frameworks, understand food recovery through a thermodynamic and systems perspective, and apply operational tools such as HACCP, SOPs and cold chain protocols. We will also focus on economic optimization, logistics, and digital integration, and learn from international best practice to design collaborative, scalable food recovery system. This cycle you see here is not just a diagram, it's the DNA of food recovery. Today, by covering this 6 fundamental stages from theory to practice with all their technical details, we aim for each of you to become a food recovery operations expert. Does this infographic design work for you? If you would like, we can further detail the color codes for these states of their specific slide correspondence. Now let us begin our presentation with the first step of this technical journey. Our goal is clear: to reduce waste by 50% by 2030 under the European Green Deal. This is not a nice to have target. It's an industrial revolution requiring a radical technical transformation in supply chain management. Our approach must not be reactive waste disposal, but proactive resource management. What we call food waste is actually just a resource that is in the wrong place at the wrong time due to failed inventory management. In this presentation, you will see how to combine economic levers like the polluter pays principle with digital traceability algorithms. As a food engineer, I tell you this: when you throw away a tomato, you are not just discarding a vegetable, you are incinerating the water, energy, and labor spent bringing in from farm to fork. Let's look at how we can demolish the monuments of inefficiency and build smart system in its place. If you are ready, let's dive into the technical detail. In engineering, there is a rule. You cannot produce a solution without knowing the design constraints. Or constraints are set by lawmakers in Brussels and Ankara. To AU's West hierarchy is not a suggestion for us, it's a thermodynamic imperative. Directive 2898 AC clearly states returning food to human consumption is superior to converting it into energy. So boasting about burning food to generate electricity is actually an admission of engineering failure. The critical concept here is the end of waste criteria. The biggest problem we face in the field is deciding when a product is waste and when it is not. It is a donatable food. Returning a product that has legally entered its waste status is a bureaucratic nightmare. Therefore, under the farm-to-fork strategy, we are reinterpreting the distinction between use-by and best-before date. Throwing away past the past is best-before date is not food safety, it's operational ignorance. Turkey's zero waste regulation and tax incentive for food banking offer us a tremendous playground. However, we must align this law with logistical reality on the ground throughout gap analysis. Legislation tells us what to do, engineering answers how. Remember, a good regulatory strategy is used the innovation space within the law, not just the gray area. Now let's put on our lab coats and go to the field. We are the back dock of a supermarket or the receiving area of a hotel. We are racing against time here. The standard operating procedure we use are too critical to be left to staff initiative. We must make the decision-making mechanism autonomous. The first step is sensor analysis and visual inspection, but saying it smells fine to me, it's not a scientific approach. Packaging integrity, vacuum loss, or mechanical damage over 10% is our red line. More importantly, thermodynamic assessment is important. Laser thermometer should never leave on our hands. In the cold chain, every degree above 4 degrees Celsius represents a microbial logarithmic risk increase. The most debated issue here is product past their best before date. As engineers, we know that best before is a quality parameter, not a safety one. If the use by date has passed, that product is biological weapon. It gets destroyed. But if the best before date has passed, it's a yellow code. It can be salvaged with sensor analysis. System that cannot make this distinction wastes tons of safe food. Our job is risk management, not risk avoidance through total destruction. If you poison someone while donating food, all your good deeds turn into a disaster in an instant. Good Samaritan laws protect you to a point, but the Clostridium perfringens bacterium does not understand laws. Especially in the HoReCa sector, recovering cooked meal is the areas of the food safety. This is where blast chilling technology comes into play. The moment the service of a meal kept warm in a bain-marie ends, the stopwatch starts. You must get that food into a blast chiller within 30 minutes. Our goal is to reduce the product center temperature from 65 degrees Celsius to 3 degrees within 19 minutes. Why? Because the range between 50 degrees Celsius and 20 degrees Celsius is where spore-forming bacteria throw a party. The faster we pass through this range, the more we prevent toxin formation. In this process, HACCP integration is not a luxury, it's a necessity, and any establishment that does not digitally record cooling curves using data loggers should not donate cooked food. As engineer, we must balance the impulse to do good with the discipline of data verification. Otherwise, we are conducting microbiology experiments, not food banking. Let's come to the most complex mathematical problem, logistics. It's commercial logistics. You know what you are carrying from point A to point B. In food rescue, you know nothing. Supply is stochastic, that is random. A hotel might say at 11 p.m. I have 50 portions of roast beef left. This is the engineering headache we call the dynamic routing problem. Trying to solve this with static routes is like writing code with a typewriter. The solution is AI-supported dynamic algorithm. Software using tabu search or genetic algorithm must instantly analyze the location, the capacity, and traffic status of vehicles in the field of revised route. The era of the lone savior is over. Food recovery is a team sport, and the players of this team are inseparably linked. We call this the hub and spoke model. Everyone's roles must be clear, and or chaos ensues. Food donors are obligated to sort products correctly. We don't tell them throw your trash at us. We say direct your resource to use us to gain tax advantage. Food banks like TDASH are our operational hub to last bastion of quality control. Logistic providers are the arteries. However, the most critical player in this system is the technology platform like Fazla, like Phoenix. Why we say this? Because they solve information asymmetry. There is someone with surplus on one side and someone in need on the other, but they don't know about each other. Technology acts as the invisible hand, matching supply and demand in seconds. In the ecosystem, trust is established through blockchain and digital data, not handshake. Let's look at Europe, especially the UK and France. What we see here is the power of technology to create behavioral change. We know solutions did not just put a scale in commercial kitchens. It installed conscience. Using computer vision technology to system recognize whether what's being thrown away is half-eaten lasagna or potato peels and instantly tells the chef, you just threw €5 into trash. This feedback reduces waste by 50%. On the other hand, in France, Phoenix started a revolution into B2B space. Yes, France has the loi Garo law banning supermarkets from destroying foods, but laws alone don't feed people. Phoenix built a digital infrastructure that makes this law enforceable. A three-channel structure: sell, donate, turn into animal feeds. This is the digitized version of the waste hierarchy, saving 120,000 meals a day is possible not just with good intentions, but with a robust software architecture. Let's go to geographies where infrastructure is insufficient or technology is used differently. The cold hubs example in Nigeria is the meeting of engineering genius with simplicity. How do you preserve food where there is no power grid? With solar energy and 120mm insulated panels. The pay-as-you-store model saves the farmer from huge investment cost. This is bringing a financial solution to thermodynamic problems. On the other hand, South Korea, a positive example of technology fetishism to pay-as-you-throw system. Citizens scan their card while dumping their waste. The system weighs it and reflects it on their bill. So the state tells the citizen, if you pollute, you pay the price. The result, 95% recovery. This is using technology to manipulate human psychology to provide environmental benefit. Tremendous example of social engineering. Returning to our country, we see proud hybrid models. The Fazla initiative is a holistic version of the We Know and Phoenix model we just mentioned, adapted to the Turkish conditions and even going beyond them. It does not just measure waste, it digitizes the documents to be submitted to the tax office with the donation model, conducts B2B sales and organize recycling. It melts legislation and technology in a single pot. On the municipal side, Başakşehir municipalities smart underground container system are a textbook example of logistic optimization. Taking garbage underground to lower to the temperature is a simple rule of physics. However, directing garbage trucks only to full containers via field level sensor in an algorithmic success that reduces the carbon footprint. Technology exists in Turkey, application exists. The only thing missing is spreading this example to national standards. In food safety, the word trust is not an emotional bond, it's technical proof. In a poisoning case, you cannot say we were doing a good deed. Article 18 of the EU General Food Law mandates one step back on one step forward traceability. You cannot do this with paper forms. A unique lot number assigned to every donation batch is the DNI of that product. But the real revolution is happening with IoT sensors and blockchain. Imagine a donation truck gets stuck in traffic and the box temperature rises to 8 degrees Celsius. The sensor instantly reports this to the cloud, and the blockchain records this data immutably. To receiving institutions see the product's history transparently. Blockchain eliminates the suspicion of did the cold chain break between parties with mathematical certainty. Engineering solutions are great, but if they are not financially sustainable, they remain just a hobby. We have to speak the language of business. When you tell them, let's save the environment, they smile politely. When you say, let's cut costs, they listen intently. This is where the polluter pays principle and the tax shields come into play. If the cost of burying a ton of waste is higher than the logistic cost of donating that product, the business rationally choose donation. To 100% tax base deduction and VAT exemption provided by Income Tax Law Article 4089 in Turkey is one of the most generous incentives in the world. Our job is to present the equation to company is an expensive waste is an expensive item on the balance sheet. Donation is a tax deductible asset. As I conclude my presentation, let's focus on the big picture. The 2030 targets are not a fantasy, they are a survival strategy. Food recovery has ceased to be an ethical choice and has become a technical and economic necessity. The formula for success rests on three pillars: measurement, connectivity, and infrastructure. My call to you, my esteemed colleagues, is this: get out of the laboratory, pick up the legislation books, and combine these two with technology. A sustainable food system will be built not by well-intentioned volunteers, but by competent engineers and strategists. Thank you for listening and see you next time. Bye.